ladies and gentlemen.
Let's solve some linear inequalities. What makes a linear inequality different than a linear equation? Well, the one major difference is instead of an equal sign, you have logic symbols in the tune of greater than or equal to, and greater than or equal to. You may also hear them with different words, especially if you're presented this as a word problem. Greater than could also be more than. Greater than or equal to could be at least, and less than or equal to could be at most. So if I want at most 12 eggs, then I could have 12 eggs, I could have 11 eggs, but 13 eggs, no good. So let's get started. So if 7z plus 3 is greater than 8, what is the least possible integer value of 7z minus 2? So first and foremost, we're not even solving for z here. We're going to solve for 7z minus 2. And if you look, my equation's pretty close. I have the 7z, but I have a plus 3 instead of a minus 2. How can I handle that? Well, I can subtract 5, and that would turn that plus 3 into a minus 2. What I do to one side, I do to the other. We're going to try to maintain the equality here, just like we did with equations. So we get 7, oh, that is awful. We get 7z minus 2 is greater than 3. So what is the least possible integer value? We want the smallest. Integer is a whole number, positive or negative, and we can't use 3 because it needs to be strictly greater than 3, so we can use 4, and that would be the least possible integer value. So keep in mind, especially for standardized tests, you're not exactly solving for the variable all the time. You might be solving for an expression. Here we go with the next one here. What is one possible value of m? Now there's something different here, and I'll talk about when we get there. So we're going to solve this like we would an equation. I want to get the variable alone on one side, and I want to get the numbers on the other. So I'm going to subtract 5, I get negative 3/4 m is less than negative 16. We can undo multiplication by a fraction by multiplying by its reciprocal. So we can multiply both sides by negative 4/3. Negative 4/3. Now, if you multiply or divide by a negative, this is where a huge difference comes in. Your symbol changes. So our less than is going to flip into a greater than, which is why I like staying positive with my variables when I was solving equations. Negative times negative is a positive. 4/3 times 3/4 is 1. So we have m, and then 16, negative 16 times negative 4 is positive 64. Divided by 3, we have positive 64 thirds. Something different, very different from a regular equation, is the fact that we can have a compound inequality. With an equation, typically you have one equal sign, you have left-hand side and right-hand side, and you just try to maintain the balance between the two. With a compound inequality, you have 3 parts. You have a left, you have a right, and you have a middle, and you're trying to maintain the balance between all of those parts. So whenever you add, subtract, multiply, or divide to one part, you're going to do it to all 3, just like you did with both parts when you had 2. So if you look here, you kind of see we have this compound inequality. We have 4x minus 1 is sandwiched in between negative 4 and 11, and we want to have a possible value of x. So one possible value, well, we need to figure this out. Let's get the x alone in the middle. So instead of getting x alone on the left-hand side or the right-hand side, we're going to get alone in the middle. So we'll undo like we always have, a minus 1 with a plus 1. That gets us negative 3 is less than 4x, which is less than 12. And then we can divide by 4 to all sides. and that gets us negative 3/4 is less than x, which is less than 3. What is a possible value of x? Well, a possible value of x could be 0, it could be 1, it could be 2, it could be 1/2. You could have any of those possible values because as long as it's between negative 3/4 and 3, you're okay. That reminds me, I didn't answer the last question. Shame on me. What is one possible value of m if m is greater than 64 thirds? Well, 64 thirds we can actually reduce. The closest number to 64 that is divisible by 3 would be 63, and that would be 21 and 1/3. So as long as we have something larger than 21 and 1/3, like 22, we're good. Sorry about that, my bad. My students will make sure to call me out for that later. All right, number 4. So same situation. If we have a compound inequality like this, what's one possible value of negative 4t? So for us now, we are going to try to make the middle, instead of just x or t, negative 4t. So first thing, we don't need the 6. We're going to subtract 6 from both sides. And that is going to make some of you uncomfy because you don't like fractions. But fractions are not scary. So to turn the 6 into a fraction compatible with the 1/8, we are going to multiply 6 by 8. 6 times 8 is 48. So we have negative 1/8 minus 48 eighths is less than 2t, which is less than 1/6. And now we need to turn this 6 into compatible with 6, which would be 36. So we're going to subtract 36 sixths. There we go. We can combine fractions by adding or subtracting the numerators. So negative 1 minus 28 is negative 49 eighths is less than 2t, which is less than, and then 1 minus 36 is negative 35 sixths. Now, how do I turn a negative 2t into a positive 2t into a negative 4t? We're going to multiply by negative 2 to everything. So we're going to multiply by negative 2 to everything. And remember, if we're multiplying by a negative, we're flipping the signs. And we're going to flip the entire thing. So this is now going to move to the right-hand side. So when I rewrite this, all of these parts are going to switch their order. So let's start with what's going to be on the left first then. Now, if I multiply this by 2, negative 2, which would make it positive, I can just reduce the denominator by a factor of 2. So that would just be 35 thirds is less than, remember the mouth was facing this fraction before, now it's going to face away. And then if we multiply this by negative 2, we get our negative 4t that we wanted is less than, and then we can reduce this denominator by a factor of 2 to get 49 fourths. Great. So we just need a number between 35 thirds and 49 fourths. Well, let's make these mixed numbers, and that'll be a little bit nicer to see. So the closest number without going over that's divisible by 3 with this would be 33, and that would be 11. It gives us 2 left, so 2/3. Here, 49 with divided by 4 without going over would be 48. That leaves us with 12 and 1/4. So what is in between 11 and 2/3 and 12 and 1/4? Well, let's make it easy. Let's just say it's 12. That's not bad. Last but not least, we have a word problem. So Rita's is planning on hiring summer workers, and each worker is expected to work 20 hours a week at $7.65 per hour. The Rita's manager has a budget of, at most, $1,200 for salaries for the week. If W represents the number of workers hired, write an inequality the manager can use to determine the number of workers they can hire. So we're not solving anything, we're just writing an inequality. So first and foremost, I see this at most 1,200. So that means that 1,200 is the absolute greatest number we can have. So we're going to put that on, I put it on the right-hand side, and then at most, we're going to put this less than or equal to. Now we need to figure out what goes on the left, and that's from the workers' paychecks. So expected to work 20 hours a week. So we have 20 hours a week at $4.65 per hour. Not $4, $7.65 per hour. I can't read. And we have W workers. That would go on the other side. Now, how do I know that this works? This is money. And we need to have the same units, just like we needed to with the equations. So let's double check that I have this right. We have 20 hours per 1 week, but this is money per week, so we're good there. The 7.65 dollars money per 1 hour. Well, hours and money cancel out. And then W is the number of workers you have. But this is all per worker, so that would cancel out with the workers as well. So you can think of it, it's $20 per 20 hours per 1 worker. So when I multiply that by W, the workers there would cancel out. So as long as it makes sense and we have units that are compatible, then we have an inequality. So let's move this over to make this a little bit nicer. This would be our inequality. We could clean it up by multiplying, but we don't really have to, so I'm not going to fuss with it. If you have any questions, let me know. Otherwise, I'll see you in the next video.